Okay, today we're going to go over some basic trig identities. Now notice the definition here at the top where an equation is an identity if the left side is equal to the right side for all values of the variable whenever the variable is defined. So here you have your quotient identities of tangent, and you can replace t with x if it makes you more comfortable. Tangent t is equal to sine t divided by cosine t. The cotangent is cotangent t equals cosine t divided by sine t. So you are asked to simplify the tangent times cosine of t, knowing that tangent is sine t divided by cosine t. If we're multiplying that by cosine t, notice your cotangents, or cosines rather, will cancel out. So all that you're left with is sine t. So much like simplifying polynomials that you have done in Algebra 2, we're now going to use trig identities to simplify. Reciprocal identities. These, yes, you will have to remember. So I won't read all of them to you because you're capable of reading them. But notice the sine t with cosecant being this inverse function, it's 1 over cosecant, cosine 1 over secant, tangent 1 over cotangent. Okay? So, much like we've done in the past, if you're given that sine t is equal to 5/13, we can find the other trig functions by drawing our triangle. Right? So this is our reference angle T with the opposite being 5, the hypotenuse being 13. We can use the Pythagorean theorem to find out that this is 12. Now we can write our other trig functions. We already got the sine, 5 over 13. That's going to make the cosine of t 12 over 13. The tangent of t would be 5 over 12. The secant of t is going to be 13 over 5. Well, I should say the cosecant. The secant of t is going to be 13 over 12. And the cotangent of t is going to be 12 over 5. Alright, so hopefully, because we've done this in the past, this part you are comfortable with. So we're going to move on. So with our unit circle, you know that your points go cosine, sine. So cosine being x, sine being y. So in this case, with the Pythagorean theorem, we're replacing x and y with cosine and sine, so that we get cosine squared t plus sine t is equal to 1. So both of these Pythagorean identities you have to remember. Okay? These you have to remember. So then off of that, if we solve for cosine squared t, we get 1 minus sine squared. And if we solve for sine squared, we get 1 minus cosine squared. You also will need to remember tangent squared plus 1 is equal to secant squared, and 1 plus cotangent squared is equal to cosecant squared. Because we will use these to simplify. Alright, so let's flip over to our next page. So we're simplifying cotangent squared t, cosine squared t plus cosine squared t. We can factor out a cosine squared t. So So cosine squared t times tangent squared t plus 1 is what we're left with. We just were shown that tangent squared t is secant squared t. So we're multiplying that by the cosine squared t. Remember, the secant squared is 1 over cosine squared t. So if we're multiplying that by cosine squared t, they will, anything over itself is 1. So we're left with 1 being what it simplifies to. Odd and even angle identities. Again, these you will have to remember. One thing to note, much like with the graphing inverse, the sine and tangent are similar in that if you have the sine over negative, the negative comes completely out, whereas with the cosine, it just remains positive. Sine, similar to tangent, the negative will pop out, and you're left with the inverse of tangent t. So that can be used as such. So if we have the sine of negative 13 power 6, that becomes the opposite of sine 13 power 6. So it's going to end up being negative 1/2 as our answer. If we have cosine negative power 6, that's the cosine of positive power 6, which is square root of 3 over 2. If we have the tangent of negative 5 power 6, that becomes the opposite of the tangent of 5 power 6. So the opposite of negative square root of 3 over 3. So our answer is just positive square root of 3 over 3. Okay. Let's look at example 5. Simplifying again. So if we have 1 over cosine times 1 minus sine squared x. Well, we know 1 minus sine squared x is going to make this 1 over cosine x times cosine squared x. So we got a square over a regular cosine. So no different than x squared over x would just be x. Our answer here, no more square, that cancels out. So we are just left with a cosine x. Okay, let's look at example 6. I'm on a new page so that I'm not squeezing it in a tight spot. So cosine x tan x minus sine x cosine squared x. So remember, cosine x times sine x over cosine x minus sine x cosine squared x. So over here, we can get rid of our cosines, so we're left with sine x minus sine x cosine squared x. So now we can factor out a sine x, which will leave us with 1 minus cosine squared x. What do we know 1 minus cosine squared x is? Sine squared x. So sine x times sine squared x is just going to be sine cubed x. And our last example is 1 plus tangent x, 1 plus tangent squared x, divided by secant, or should I say cosecant squared x. So it's good to write things in terms of sine and cosine. It kind of makes it easier. But in this case, we know 1 plus tangent squared is secant squared. So we can write secant squared x over cosecant squared x. So if we were to write them in terms of sine and cosine, we have 1 over cosine squared x divided by 1 over sine squared x. And what happens when you divide? You have to multiply by the reciprocal so that we get 1 over cosine squared x times sine squared x. So sine squared x over cosine squared x is just going to leave us with, if tangent is sine over cosine, this is just going to be tangent squared x. So hopefully you understood most of this, and we will practice further in class.